In the ever-evolving tech landscape, artificial intelligence, AI, machine learning, ML, and generative artificial intelligence, Gen AI, stand as transformative pillars. Beyond industry buzz, they signify a paradigm shift in problem-solving, decision-making, and creativity. Imagine a machine mastering a complex game and adapting in real time. Picture a tireless customer service assistant learning for personalized responses. Envision a self-driving car continuously improving safety features through AI-driven updates. In this video, we will delve into the salient characteristics of artificial intelligence, AI, machine learning, ML, and generative artificial intelligence, Gen AI, along with their respective applications. We will then explore how AI, ML, and generative AI work together to create wonderful experiences. Artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. It encompasses a wide range of technologies and techniques designed to enable machines to perform tasks that typically require human intelligence, such as rule-based systems, expert systems, machine learning, and generative approaches. Machine learning and generative AI are subsets within the broader domain of AI, representing specialized approaches to achieving intelligent behavior in machines. AI systems aim to generalize knowledge across a broad range of tasks. They are capable of solving complex problems, often with a focus on mimicking human cognitive functions. AI systems can adapt to new situations and learn from experience. Let's explore 5 popular AI use cases. The first use case is AI in personalized medicine. Traditional medicine often follows a one-size-fits-all approach, but AI allows for tailored treatments based on individual patient data. Machine learning models analyze genetic information, medical history, and lifestyle factors to predict how patients will respond to specific treatments. This enables healthcare professionals to design personalized treatment plans, optimizing efficacy and minimizing side effects. AI's ability to interpret complex biological data sets it apart, offering a more precise and patient-centric approach to medical care. The second use case is AI in human resource management. In the realm of HR, AI is reshaping the hiring process. Unlike traditional methods, AI-driven tools analyze resumes, assess candidate skills, and even conduct initial interviews. Natural language processing, NLP algorithms help in understanding the nuances of job descriptions and resumes, ensuring a more accurate match between candidates and job requirements. This not only saves time, but also reduces biases in the recruitment process, emphasizing merit-based selections. The role of AI in automating and optimizing HR tasks showcases its versatility beyond conventional ML applications. The third use case is AI in energy grid optimization. Unlike ML, which might focus on predicting energy consumption, AI algorithms actively manage and optimize the distribution of energy in real time. Reinforcement learning models, for instance, can dynamically adjust energy distribution based on demand patterns, weather forecasts, and system constraints. This enables a more resilient and responsive energy grid, showcasing AI's role in decision-making and control in complex systems beyond the typical ML predictive analytics. The fourth use case is AI in wildlife conservation. AI becomes a conservation ally, assisting in wildlife monitoring and protection. Instead of relying solely on ML for pattern recognition, AI integrates computer vision and sensor technologies to actively monitor wildlife habitats. Drones equipped with AI algorithms can detect and track endangered species, identify poaching activities, and even assess the health of ecosystems. The proactive role of AI in conservation showcases its capacity for real-time monitoring and decision-making beyond the usual ML pattern recognition tasks. The fifth use case is AI in disaster response and management. While ML might predict disaster occurrences, AI goes further by actively coordinating emergency responses. AI algorithms process real-time data from various sources, including satellite imagery and social media feeds, to assess the extent of damage, identify areas needing immediate attention, and optimize resource allocation. This level of dynamic decision-making distinguishes AI in disaster management, showcasing its ability to actively respond to evolving situations, a characteristic not typically associated with traditional ML approaches. From personalized medicine and HR management to energy grid optimization, wildlife conservation, and disaster response, AI demonstrates its versatility in actively making decisions, optimizing processes, and contributing to solutions in various domains. We will now explore machine learning. Machine learning, ML, is a subset of AI that focuses on the development of algorithms and statistical models that enable computers to improve their performance on a task through learning from data without being explicitly programmed. ML models are capable of learning patterns and making predictions from data. It involves the training of models on datasets to recognize patterns, generalize information, and make decisions without being explicitly programmed. ML is a foundational element within AI, and many AI applications leverage machine learning techniques to enhance their capabilities. ML algorithms learn patterns and relationships from data. They can adapt and improve their performance as they are exposed to more data. ML is often used for making predictions and classifying data into categories. Let's delve into 5 popular ML use cases. The first use case is ML in predictive maintenance for industrial equipment. ML algorithms analyze historical and real-time data from machinery to predict potential failures. By identifying patterns indicative of equipment wear and tear, ML models can forecast when maintenance is needed. This proactive approach reduces downtime, extends the lifespan of equipment, and optimizes maintenance schedules. ML excels in making predictions based on data patterns, showcasing its specificity in addressing predictive analytics challenges within industrial contexts. The second use case is ML in credit scoring for financial institutions. ML algorithms process vast amounts of financial data to assess creditworthiness. By analyzing variables such as credit history, income, and debt, ML models generate credit scores, aiding financial institutions in making informed lending decisions. The predictive power of ML distinguishes it in this use case, where precise risk assessment is crucial for responsible lending practices. The third use case is ML in speech recognition for virtual assistants. Machine learning plays a pivotal role in speech recognition for virtual assistants. Unlike the generative capabilities of GII, ML models, particularly those based on deep learning, analyze audio data to convert spoken language into text. These models, trained on extensive data sets, can accurately recognize and transcribe speech, enabling seamless interactions with virtual assistants. ML's specialization in pattern recognition within audio data sets it apart in this use case, emphasizing its role in transforming spoken language into actionable information. The fourth use case is ML in image classification for healthcare diagnostics. ML models, often based on convolutional neural networks, CNNs, analyze medical images such as X-rays or MRIs to identify abnormalities. Trained on labeled datasets, these models can assist healthcare professionals in detecting diseases and conditions with high accuracy. ML's proficiency in learning and recognizing patterns within visual data distinguishes it in this specialized diagnostic application. The fifth use case is ML in dynamic pricing for e-commerce. ML algorithms process vast amounts of data, considering factors like demand, competitor pricing, and customer behavior to dynamically adjust prices. MML models, often using reinforcement learning techniques, learn from ongoing market dynamics to optimize pricing strategies in real time. In these narratives, we've explored distinctive machine learning use cases, showcasing its strengths in predictive maintenance, credit scoring, speech recognition, image classification for diagnostics, and dynamic pricing. Generative artificial intelligence, Gen AI, refers to AI systems that can generate new content, often in the form of text, images, or other media. These systems use techniques like deep learning and neural networks to produce novel and creative outputs based on learned patterns from existing data. Gen AI often incorporates machine learning techniques as a fundamental part of its architecture. Gen AI focuses on generating content that is not explicitly present in the training data. It can simulate an imaginative process, creating something original based on learned patterns. It can produce diverse outputs, making them useful for creative tasks. Let's explore 5 popular Gen AI use cases. The first use case is Gen AI in creative content generation. Gen AI models, such as OpenAI's GPT-3, are designed to generate human-like text, offering a powerful tool for content creation. These models learn from massive data sets and can produce coherent and contextually relevant written content. From writing articles and stories to generating marketing copy and social media posts, Gen AI's unique ability to generate creative and contextually appropriate content sets it apart in the realm of creative writing and communication. The second use case is Gen AI in artistic image generation. Models like DALL-E, another creation from OpenAI, can generate images based on textual descriptions. Unlike traditional ML image classification, which identifies existing patterns, Gen AI models can imagine and create entirely new visual concepts based on textual prompts. The third use case is Gen AI in music composition. Models like Magenta Studio use Gen AI techniques to compose original music by learning from extensive musical datasets. Unlike traditional ML applications in music, which may focus on pattern recognition, Gen AI in music composition involves creating entirely new pieces, demonstrating its unique ability to contribute to artistic expression. The fourth use case is Gen AI in conversational chatbots. While traditional AI-driven chatbots may rely on pre-programmed responses, Gen AI models, such as chatbots powered by GPT-3, can engage in more natural and context-aware conversations. Gen AI's unique strength lies in its ability to understand and generate human-like language, making interactions with chatbots feel more dynamic and lifelike. The fifth use case is Gen AI in video game design. Models like OpenAI's DALL-E and GPT-3 can assist in generating characters, landscapes, and even narrative elements based on textual or visual prompts. Unlike traditional procedural generation techniques, Gen AI in video game design introduces an element of unpredictability and creativity, enriching the gaming experience with novel and unexpected elements. These applications highlight Gen AI's unique capacity to generate novel and creative content, moving beyond traditional AI and ML functionalities to contribute to artistic and interactive domains. Let's now look at the dynamic and evolving relationship between AI, ML, and Gen AI. As AI technologies progress, advancements in ML and Gen AI contribute to the iterative development of more sophisticated and capable AI systems. AI, ML, and Gen AI often collaborate in integrated systems. For instance, a holistic AI system might use machine learning for data-driven decision-making and generative models for creative tasks, demonstrating the synergistic integration of these components. Let's explore integrated customer experience enhancement use case that seamlessly integrates AI, ML, and Gen AI to address a complex business challenge. This uses AI for personalized customer interaction. An AI-driven customer relationship management (CRM) system is implemented to understand customer preferences, behavior, and history. The AI system uses natural language processing (NLP) to analyze customer interactions, including emails, chat logs, and feedback, providing insights into sentiment and preferences. This helps in improved customer service through personalized interactions. As the AI system tailors responses based on historical data and real-time customer sentiment. Integrated customer experience enhancement also uses ML for predictive customer behavior analysis. Machine learning algorithms are employed to predict future customer behavior and preferences. ML models analyze historical data, purchase patterns, and customer interactions to predict products of interest, potential churn, or the likelihood of engagement with marketing campaigns. This helps in enhanced decision-making as the organization can proactively address customer needs, offer targeted promotions, and optimize inventory based on predicted demand. Integrated customer experience enhancement also uses Gen AI for creative content generation. A generative artificial intelligence model is integrated to create personalized and engaging content for customer communications. The Gen AI system generates creative and personalized content, such as marketing copy, product recommendations, or promotional material based on learned patterns and customer preferences. This helps to create unique and compelling content that captures the attention of customers, fostering brand loyalty and engagement. The integration of AI, ML, and Gen AI creates a holistic customer experience enhancement system where AI handles personalized interactions, ML predicts customer behavior, and Gen AI generates creative and tailored content. This integrated approach not only enhances operational efficiency in customer interactions, but also fosters innovation by using Gen AI to bring creativity and personalization to marketing strategies. In summary, while AI is the broader concept of machines exhibiting human-like intelligence, ML is a specific approach within AI that involves learning from data. Gen AI is a subset of AI that focuses on the creative generation of content. Each of these fields has its own set of applications, with AI spanning various domains, ML excelling in data-driven tasks, and Gen AI contributing to creative content generation.